Bismillahirrahmanirrahim. Class first year, subject Maths, and lecture number 17. In this lecture, we discuss exercise 2.6 questions. Firstly, define binary relation. Let A and B be two non-empty sets. Then any subset of Cartesian product A cross B is called a binary relation or simply a relation from A to B. According to it, we solve exercise. Question number 1. Here is a subset given A whose element is 1, 2, 3, 4. He said that you find relation in A and find its domain and range, and also find the graph of each. Here is 4 parts given. Firstly, we find Cartesian product of A and then A cross A, and then we solve further parts. Firstly, here is set A given. We take its Cartesian product A cross A such that first element of A multiply with the all elements of the second subsets 1, 1, 1, 2, 1, 3, 1, 4 in the pair form, and next 2 multiply with the all element of the second subset, and similarly 3 multiply with the all element of the second subset, and similarly multiply 4 with the all elements of second subsets. These all are the Cartesian product of A cross A. In this part, all the first elements are said to be domain and all the second elements are said to be range. Now we are starting our actual question, part number 1. In a part number 1, here is a pair form elements given x comma y such that y is equals to x. We are finding firstly relation because he said that both x and y are equal, so we check in Cartesian product where the elements are same. We write those elements in its relation like 1, 1, 2, 2, 3, 3 and 4, 4. These all are the relation of part number 1. Now we making its diagram. Firstly, draw x-axis and y-axis and put point at 1, 1 and put dot at 2, 2 and put also dot at 3, 3 and 4, 4, because this is our required points according to the part number 1. Now he said that you also find the relation of this relation domain and range, and you know all the first elements of these pair are said to be domain and all the second elements of this pair is said to be range. So domain of R1 is 1, 2, 3, 4 and range of R1 is also 1, 2, 3, 4, because in this case we are discussing the same elements. Part number 2. In a part number 2, here's a pair given x comma y such that y plus x equals to 5. Means we add the value of x and value of y such that result is equals to 5. So we check in the Cartesian product A cross A which elements given results 5. 4, 1, this gives results 5, 3, 2 gives result 5 and 3, 2 gives result 5 and 4, 1 gives result 5. So we write all these elements in its relation and give this relation name R2. So now make its diagram. Firstly, draw x-axis and y-axis from origin. Firstly, put point 4, 1 and 3, 2 and dot at the point 2, 3 and dot at the point 1, 4. In this way our diagram of this part is complete. Also finding the domain and range of this relation, we are giving the name to this relation R2. So the domain of R2 is 1, 2, 3, 4 because the first element of these pairs of R2 is 1, 2, 3 and 4. Range of this relation R2 is 4, 3, 2, 1 because the second element of these relation R2 is 4, 3, 2 and 1. In this way we solve part number 3. In this question he said that x comma y is a pair given such that x plus y result less than 5. We are checking similarly from the Cartesian product A cross A, which elements give the result less than 5? 1 1 1 2 1 3 2 1 2 2 and 3 1. These all elements give result less than 5. Now making its diagram, firstly draw at the point 1 1 and secondly draw at the point 1 2 and now meet at point 1 3 and now dot meet at the point 2 1 and now dot meet at the point 2 2 and also meet at the point 3 1. And the similar way we are giving the name this part relation R3, and the domain and range of R3 is, domain of R3 is 1 2 3 because the first element is 1 2 3. Where the elements are repeated, don't write in domain repeated, just write one time, because here 1 is repeated 2 times in domain, 2 is repeated 2 times in domain, but you write just in one time in domain when we are written domain in the bracket form. So domain of R3 is 1 2 3 and range of R3 is 1 2 3. Similarly, part number 4, elements are given x, y such that x plus y result greater than 5. Similarly, we check from the Cartesian product A cross A which elements give result greater than 5. 2 4 3 3 3 4 2 4 3 4 and 4 4. These elements give result greater than 5. Now make its diagram. Here is x-axis missing. You also draw x-axis and y-axis, and firstly meet point at 2 4 and then meet 3 3, then meet 3 4 and after that meet point 4 2 and after that you meet at the point 4 3 and 4 4. And this relation is represented by small r2 r4. So its domain is first elements, which is 2 3 and 4. Repeated element don't write again and again in domain, just write one time. And range of this is 4 3 and 2. Now we define function. A binary relation f is called a function if there is no repetition in the domain of f. It is written as f from a to b. Firstly, we define into function. In an into function, if a function f from a subset a to b is such that range of f is not equals to b, then f is called an onto function. Here is an example given. For example, f is 1 2 3 4 and 5 6. We are here, domain is 1 3 5 and range is 2 4 6. First, a subset element is said to be domain and b subset element is said to be codomain, but those elements which meet with the elements of a is said to be the range. Now define onto, which is also called a surjective function. If a function f from a to b is such that range of f equals to b, then f is called onto or surjective function. For example, here is a function given whose element is c1 m1 c2 m1 and c3 and m3. Now we making its diagram such that a subset have elements c1 c2 and c3, b have elements m1 m2. Now join c1 with m1, c2 with m1 and c3 with m2. This is the example of onto surjective function. After that we discuss one-to-one and into, which is also called injective function. If f is into function and there is no repetition in the range of f, then f is called injective, one-to-one and into functions. For example, f is given whose element is 1a 2b. Firstly, we write the subset a elements and subset b element. One we meet with the a and 2 meet with the b and c is as it is. Similarly, one-to-one and onto, which is also called a bijective function. If f is an onto function and there is no repetition in the range of f, then f is called a bijective and onto function. For example, function is given whose element is az, bx and cy. Firstly, draw the subset a and secondly subset b. A meet with z, b meet with x and c meet with y. Similarly, we are solving question number 3. using all these definitions which we have to discuss in previous. Which of the following diagram represent a function and which type? Firstly, here is a subset A and subset B given. You tell me, is it function? No, it is not a function, because in the definition of function there is no repetition in domain, but here there is a repetition in domain, so this is not a function. In a part number 2, this is one-to-one and on-to function, bijective function, because according to the definition of bijective, each element multiply with the each element of B. So this is example of bijective function. And part number 3, in a part number 3, this is 1 1 and on to, which is also a bijective function, and its domain is 1 2 3 and its range is A B C. And part number 4, whose elements is L M N in domain and in range X Y Z. This is a into function. And here our lecture is complete. We will inshallah meet into the next lecture. Thanks students for watching.